Hello and welcome to this video. In this one we're going to be looking at slope. So first we're going to look at the definition, and then I'm going to explain one area where it's quite important. So slope of a line segment is a measure of its steepness. So a line could be really steep, it could have a really high kind of angle, or it could be less steep, or it could have kind of no steepness and just be kind of horizontal, and we're going to look at some of those down below in a sec. But one area where steepness or slope is going to be really important is on roadways. I don't know if you guys have ever seen a road where it says the percentage of the grade of the slope. Sometimes you'll see that in the mountains and it'll say a certain number, and that gives drivers an indication of how steep the hill is, because if they're maybe like a trucker and it's a really steep hill and their brakes go out on them, that's not going to be a good case. So for us in math, slope is this formula. It is the rise over the run. And the way to kind of think about that is, if you think about this line here, to figure out how steep that is, you need to know how far over you went and how far up you went. That's going to tell you how steep this is. If you rise a lot, that's going to make it steeper. If you don't rise, that's going to make it less steep. So slope is rise over run. Another way to write that is it's the change in the y. So this would be the change in the y going up and down, change in the y, divided by the change in the x. And the change in the x is going this way. So that would be the change in the x. And that's just because this is the x-axis and this is the y-axis. So these symbols here, what those mean, I've said it, but what they actually mean is the change in. So it's the change in the x and the change in the y. So visually on a graph, this is what slope looks like. It's your rise divided by your run. That's this formula here. But we need to know what those two things are. And there's going to be some different cases of slope. So in this one, it's called positive slope. I'm just going to show you all the different cases that we can have. So positive slope, the way you can think about that is if this was like your money and your money was increasing and going up, that would be a positive thing. That would be good. If your money was going down, that would be bad. So that would be negative. So we have negative slope. If your money was just flatlining, so it's not increasing and it's not going down, you could think that your money is at zero. There's zero change, so your slope is zero. So the reason that you have a slope of zero is because there is no rise. It doesn't go up and it doesn't go down. Now the last one there for slope is undefined. The reason for that is because if I asked you the question, how much does this line rise? Well, this line, it just keeps going up and up and up at this one spot. So you can't actually gauge or calculate the amount of rise that is occurring there. So you can't calculate the amount of rise, so we say the slope is undefined. I'll kind of explain down below when we actually calculate with some numbers why it's undefined, as well as we'll see why it's actually zero, why it's actually negative, and why it's actually positive. So looking at our examples here, it says classify the slope of each line segment as positive, negative, zero, or undefined, and then we're going to calculate it by using rise over run. So first we're just going to go through and label them as positive, negative, zero, or undefined. So if you want to try to do that first on your own, you can pause the video now and label them all as those four options. So I'm just going to go through kind of starting at this one and then going from left to right. So the line here from D to C, that one is straight up and down. So that one is undefined. So you can't calculate the slope of that one. It's undefined. This one, G to H, that one's going downwards if we're going from left to right. So that is negative, right? That was like our money going down. So that is bad. So it's negative. This one, A to B, it's going up. So that is positive. This one, K to L, that's like our money is flatlining. So we have zero change in our money. So the slope is 0 for that one. This E to F, that one's going down. So that one is negative. And then the last one there, I to j, that's going upwards, so that one is positive. Okay, so we've gotten all of the slopes on there. Okay, so now that we're done that, we can go to the second part where we're actually going to calculate the slope of each one of these. So to write out the slope, you're going to put slope, and then this is called subscript. It's kind of lower. It's kind of the opposite of an exponent. It's actually down below. So we got slope of AB. That means the slope from the line A to B. So looking at that one was right here. So what we want to do is we want to count how much it rised and how much it ran. So we are going to count that. It rose 1, 2, 3, 4, 5, 6, 7. So it went 7 up. And then it went 1, 2, 3, 4, 5 over. So that is 5. So our rise is 7. And then our run is 5. For C to D here next, what we're going to do is we're going to figure out our rise and our run. So it rised 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it was 10 up. But it did not move left and right. So it didn't run at all left or right. So we have a rise of 10, and then our run is 0. And 10 divided by 0, if you tried to calculate that, you can't. You can't divide by 0. So this is how we get undefined. So it's undefined, you can't actually calculate it. Next one, E to F. So E to F is right here, and we're going to go over 1, 2, 3, 4, and then down 1. So that was over 4, and then down 1, and down has to be negative, so negative 1. So our rise was negative 1, down 1, and we went over 4. So that is another way how you can check to see whether the slope is positive or negative. You actually get a negative answer if it has negative slope. Whereas for our positive one up here, it was positive slope, so you get a positive answer. Next here, we're on slope from G to H. So G to H, that is this one right here. So counting how many times that one fell down, that is 13 if you want to count it, but it's down, so it's negative 13. And then the amount of run, it moved over, you can see it moved over a half, and then it went another whole hop there. So it went 1.5 over. So we're going to write that, 1.5. And then if we wanted to simplify this, to get rid of this decimal, what you can do is you can multiply by 2. So when we do that, we get negative 26 over 3. And we'd rather not have decimals. That's why I just changed it into the one without decimals. But technically, both of these would be correct. So next one now, slope I to j. So for that one, we went up 1, 2. So our rise is 2. And then our run is 1, 2, 3, 4, 5, 6. So it's 2 over 6. And now 2 over 6, we can actually simplify this. Divide the top by 2, you get 1. Divide the bottom by 2, you get 3. So all I did there was divide that by 2 and divide that by 2. It's always got to be the same number. Okay, and then the last one we had is the line slope from K to L. So that one we go over 1, 2, 3. So it's, remember, rise over run. So the run is in the bottom. So we went over 3. But we did not rise or fall. So we didn't go up or down. So that is a 0. And 0 over 3 is equal to 0. So that's how you get a slope of 0. Like how we set up here. When it's flatlining, it's because when you actually calculate it, you'll get 0. Okay, so this is how you would calculate the slope if you wanted to just count your points and you could literally see your line on the graph. What we're going to do next is we're going to go over this formula, and we're going to do some questions where you're just given points and you can use this formula to figure out what the slope is without even being given a graph like we were here. Okay, so the slope formula, it says the slope of a line can be determined using 2 points of the line. You always have to have at least 2 points. And we're going to label those points on the line x1, y1, and then we'll label our second point x2, y2. So this formula that you guys see here, this is actually on your formula sheet, so you don't have to worry about memorizing it. Another way to write it though is, like we had on the front, is change over y over change in x. Because that's what this is doing. You're going from one y to another, so that's a change in y, and one x to another, that's a change in x. So the one good thing about this formula is that the order of your points that you're given, it actually doesn't matter. So it says right there, it does not matter which one is x1, y1 or x2, y2. You can label them however. You're always going to get the same answer. So let's go through these examples. It says determine the slope of the line passing through each pair of points. So what you should do in every single question that you get is first label those points. So I'm going to call this one x1, y1, and then I'll call this one x2, y2. And then what we do is we start with our formula. So it's y2 minus y1 over x2 minus x1, and then we just got to calculate this. So y2 was -2, so I'm going to put that in here. Subtract y1 is a 4. Divided by, and then x2 is right here, that's -1. And then subtract x1, that was a -3. So you got to put in the -3. Now these two negatives, they're going to cancel out, and that's going to give me a positive. So we'll do that in the next step. In the numerator though, -2 minus 4, that's just -6. And then here, those two we said that's going to give us a plus. So -1 plus 3, that's +2. And then -6 divided by 2, that equals -3. So there's your slope. One thing I forgot to mention is slope. We're going to be using m to represent slope. That is also what's in your formula here. Okay, so looking at the second one here now, again, first thing, always label your points x1, y1 and x2, y2. So what I'm going to do is I'm actually going to label this one x1, y1, and I'm going to call this one x2, y2. And again, the order of it, it doesn't matter which one is which, you have to get the same answer. So if you want to try flipping them and doing it the other way, you'll still get the same answer. What you cannot do though is you can't have like x1 and a y2. These both have to be 1s, these both have to be 2s, but I could put the 2s over here and I could put the 1s over here. So again, the next thing we want to do is start with that formula and then just plug it in. So y2, that's right there, that's 6. So 6 subtract y1, that was a 2. So we got that. Divided by x2, that was -3. Subtract x1, that was a 5. And then simplify, 6 minus 2 is 4. And then in the denominator, -3 minus 5, that's -8. And then to simplify that, I can divide the top by a 4 and the bottom by a 4. So that gives us 1 over 2. And now this negative, usually we don't like to put it in the bottom. Usually we like to put it in the top, or we put it out front. Either of those locations is fine. You could put it in the bottom, but usually we put it in the numerator or out in front. So we're done number 2. Looking at number 3 here now, I'd like for you guys to try to do this one. So if you want to pause the video and then work on that one. So hopefully when working on that, you labeled your points, x1, y1, and then x2, y2. If you labeled it the other way, it's not going to matter. So once you had that, then you should have wrote out your formula. And then we're going to substitute into that. So y2 is a 4 for me, the way I labeled it. And then minus y1, that's a 4, divided by x2 was 5, subtract, and then x1 was that -2. Okay, so in the numerator, 4 minus 4 is 0. In the denominator, 5 minus -2, that's actually plus. So we're going to get 7. And 0 divided by 7 is 0. So our answer for that one is 0. On to number 4 here now, and this one we're going to do together again. So I'm going to label my points here first, x1, y1, x2, y2. And then after that, start with our formula, and then we just fill it in. So y2 is 3 minus y1, that's a -2, divided by x2, that was the 1 right there, so we got a 1, minus x1, that's also a 1, so I have that. In the numerator, the minus minus is actually a plus, so we got 3 plus 2, that's 5. But in the denominator, we got 1 minus 1, that's 0. And 5 divided by 0, that is equal to nothing. We can't calculate that. That is undefined. If you ever forget that dividing by 0 isn't allowed, just try putting it into your calculator. It'll give you out an error. Or think about it in, say, a real world idea. If you had 5 out of 0 on a test, that wouldn't make sense. There's no way you could get 5 questions correct out of 0 questions. Or you couldn't take like 5 people and then divide them into 0 groups. That also wouldn't make sense. So the last one here, number 5. Now this one again, I would like you guys to try to do this one. So pause the video and try to work out that one. So again, hopefully the first thing you did was label your points. I'm going to go backwards and see if you maybe did it the other way, and then we'll see if we get the same answer. So I'm going to call that one my x1, y1, and I'm going to call this one x2, y2. So first thing, start with our formula, and then we're going to plug in. So y2 is 3 minus y1 is an 8 divided by x2, that's negative 5, subtract x1, that was a 3. So in the numerator, 3 minus 8, that's negative 5. And then in the denominator, negative 5 subtract 3, that is negative 8. Those two negatives are going to cancel, and so I get 5 over 8. And hopefully you got the same thing. Regardless if you had these labeled the other way, you're still going to get 5 over 8. So that was our last practice question. I'm just going to put up our textbook questions here now at the bottom. So it's page 325, and we're doing numbers 1 to 3.